Today's lesson will be studying trigonometry, specifically identities and equations. So it's grade 12 trigonometry. So what we need to know is like the basic formulas. So let's go over the basic formulas that is required to prove identities and to solve trigonometric equations. So we know the grade 11 formulas that we learned, right? We have a sine squared theta plus cosine squared theta is equal to 1. And we also learned that tan theta is equal to sine theta over cos theta. Now, the grade 12 formulas that we need to know are obviously all the compound angles, right? Which is not so bad. It's just that in compound angles, they hardly test you on, the compound angle itself. They ask you mostly for double angles. So let's look at the double angles. We know sine 2 theta is just 1, which is 2 sine theta, cos theta. And cos 2 theta, there's 3 of them here. That's where the problem is. You don't know which one to choose, but there are tricks in proving identities, and you know exactly which one to choose from the cos 2 theta double angle, the cos double angle. So we know it is cosine squared theta minus 1 minus sine squared theta. Cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, and is 1 minus 2 sine squared theta. Right, so these are the formulas we need. And also you need the formulas for compound angles, right? We already know the formula for compound angle, which is cos A minus B is cos A cos B plus sine A sine B, right? And obviously if there's a plus there, the plus will be followed by a minus. And for sine, you start with sine and you end with sine, right? So we have sine A plus B. What is sine of A plus B? Which is sine A cos B plus, for sine, the sign remains the same. Cos A sine B, right? And the minus is followed by a minus. So these are all the formulas you need. You don't need to stress about the grade 11 formulas because that is quite simple. You just need to worry about this one here. You just need to select the correct one, which is cos double angle, right? Cos 2 theta angle. That's the only one that you need to worry about because those three are quite simple. Right, so now let's look at some examples in proving identities. Right, so when we are proving identities, we need to make the left-hand side equal to right-hand side, okay? So we are going to say left-hand side is now equal to left-hand side is equal to 1 over cos x remains as 1 over cos x. We can't do anything. Okay, you can't simplify anything here because everything is already in terms of sine as sine and cos. So this is more like a grade 11 identity problem. So what you're going to do is find LCD. The LCD here is clearly cos x into 1 plus sine x. Right? Cos x cancel out. You're left with 1 plus sine x. So 1 times 1 plus sine x is just 1 plus sine x minus cos x times what? 1 plus sine x and 1 plus sine x cancels out. So you're left with cos x as a factor times another cos x. So what you are left with is, look at here what we have. We have 1 and we have 1 minus cos squared. So let's write that out. We have 1, put the plus sine x at the end, right? And see this cos x times cos x, put it here, which is 1 minus cos squared x. Now group that up. What is 1 minus cos squared x? Right, it's an identity, right? What type of identity it is? Look at it. 1 minus cos squared is sine squared x. So we're going to change that into sine squared. over the same LCD, which is cos x into 1 plus sine x. 1 minus cosine squared is sine squared x plus sine x divided by cos x into 1 plus sine x. Guys, I'm just going to write LCD here for, okay. Let's just write cos x into 1 plus sine x. Now you can see the top, it has to factorize, so we can cancel out the 1 plus sine x, okay? So we're going to take out sine x here. And we are left with 1, we are left with sine x plus 1 divided by cos x into 1 plus sine x. Now you can clearly see, remember we are factorizing the top, so sine squared x, sine x is common to both because there's 2 of them there. So you took out 1 sine x, right? HCF. So sine squared divided by sine x is sine x divided by sine x is 1. So that one and that one cancel out. So what are you left with? You are left with sine over cos, sine x over cos x, which is clearly equal to tan x, which is the right hand side. Okay, hope you guys understood that. Let's look at the next one. We got 1 minus cos 2 theta divided by sine 2 theta is equal to tan theta. How? How is this possible? Right, so the idea over here is not to expand cos 2 theta anyhow. Let me copy this and put it here, right? So we have cos 2 theta. Let's block this off. I only want that identity, right? Cos 2 theta. Now let's try to think of what to substitute inside here. Which identity should we go and substitute inside cos 2 theta so it can simplify our life, right? Because it's a double angle. Double angle means I need to replace the double angle with one of these identities. I will go and replace it with the third one. Why? Because I can cancel out the one. The one is causing a problem here, okay? So I'll replace the one, not replace the one, sorry. I will replace the cos 2 theta with the last one. So I've got 1 minus, what is cos 2 theta? 1 minus 2 sine squared theta. Right? And then the denominator, simple, what is the denominator? Sine 2 theta is just 2 sine theta cos theta because you only have one of them there, right? There's only one single double angle identity, which sine 2 theta is 2 sine theta cos theta, as you see here, right? Now, you can clearly see 1 minus 1 cancels out, and then minus and minus. So you can write it down 1 minus 1, and then minus times positive, the negative is positive 2 sine squared theta divided by 2 sine theta cos theta. Guess what now? The 1 and the 1, that is out, right? That cancels out, right? Then you can cancel out the 2 with the 2 sine theta with the 2 sine theta. So what are you left with? Sine theta over cos theta. Okay, and that is also tan theta, which is equals to right hand side. I hope you guys are understanding. Okay, any questions? Excellent. No. Hey, that was quite simple. It's just a matter of choosing the correct double angle for cos. That's it. Let's have a look at this question here now. Prove the identity. We have sine 2x plus 1. So I'm just going to write it here. Left hand side is equal to sine 2x plus 1. Now we don't have an option for sine 2x plus 1 because see sine 2x is already what? 2 sine theta cos theta. 2 sine x cos x. Just be careful with the variable is x now. Plus 1, right? And cos 2x. Now how do we know what to expand cos 2x in terms of? Now because you expanded sine 2x as 2 sine x cos x, you went and put sine and cos mixture there. So what I suggest is expand the 1 as well. Don't leave the 1 there. Expand the 1 as well in terms of sine and cos. So if you're going to expand the 1 in terms of sine and cos, you basically going to just substitute the identity, okay? So what is 1? Sine squared plus cos squared. All right, that's what a 1 is. The 1 is basically equal to sine squared plus cos squared. Now, look at the cos 2x. The cos 2x, because you expanded everything in terms of sine and cos, expand the cos 2x in terms of sine and cos. So that is just cosine squared x minus sine squared x. How do we know that? Look at the cosine minus sine squared is that. Now, guess what? When you are trying to factorize this, it's nice. You have to factorize. The denominator is difference of two squares. But what about the numerator? The numerator is in this order. Look at this. The denominator is cosine squared minus sine squared. Okay, I will do the factorization in the next step. Let's rearrange this into a trinomial, because if you're factorizing the bottom, then we need to factorize the top as well. So how should we factorize it? Put the cos squared right in the front. Cos squared x, and leave the sine squared right at the end, because we're trying to make a trinomial, and this is 2 sine x cos x. Okay? Perfect. So this is a perfect square. And what is cos squared minus sine squared? That is cos x minus sine x into cos x plus sine x. Perfect. Now, next step, we said this is a perfect square, which is just basically cos x plus sine x, or you can multiply it out like this, cos x plus sine x. Now, how do we know that? Because it's in the form, a plus b squared is equal to a squared plus 2ab plus b squared. That's our form, okay? Squaring a binomial form. That's what the form is. So that's the reason why I factorized it in that form, right? You can't forget basic stuff now. Squaring a binomial, difference of two squares, right? Those are basic stuff that you need to know all the way from grade 9. Now, anyways, let's continue factorizing this. And now you see you have cancellation. If you continue factorizing this, you got cos x minus sine x, right? Into cos x plus sine x, right? And now you can see that terms will cancel out. Top cancel one from the top, one from the bottom. And now we are left with cos x plus sine x, right? Divided by cos x minus sine x, which is clearly equals to the right hand side. Now, look at what the second part of this is asking us for. For which values of x will the identity above be undefined or invalid? Undefined means when the denominator is 0. So you need to look for every single denominators that you have on every single fraction. So I have a denominator on the left hand side and I have a denominator on the right hand side. So I'm kind of like solving an equation here for undefined. When will what values of x will this be undefined? So we need to say when denominator is 0, undefined when the denominator is 0. Denominators must be equal to 0, okay? So what are the denominators? We got cos 2x, which is equal to 0, or cos x minus sine x is also equal to 0. Cos x minus sine x is also equal to 0. Now you have to find general solutions for both. And both of them are like grade 11 trigonometry. This is all grade 11. This wasn't grade 11 because we had to expand cos 2x. Anyways, let's solve this. These are grade 11 equations to solve. So we're going to say a reference angle when is cos 2x equal to 0, or when is cos a reference angle will be, let's write RA for reference angle. So the reference angle is equal to cos of what is 0? Cos of 90. Reference angle is 90 degrees. Now, where is cos 0? So you're going to say a reference angle is 2x is equal to 90 degrees plus, when is cos equal to 0? When is cos 2x equal to 0? So it's nice to remember the trig graphs for this part. Remembering the trig graphs is really useful because I'm trying to answer this question. When is reference angle was what? 2x. When is cos 0? Cos is 0 every, it starts at 90 degrees, right? And every, what interval? 90, every 180 degree interval, you'll get the cos hitting the x-axis at 0 because the next cut will be at 360. No, not 360. That is 180. The distance between them is 180. Sorry, it should be 90, and there should be, yeah, that is 90. That should be 270. That should be 450 degrees. So you can clearly see every 180 degree interval. Okay. So you're going to say 90 degrees plus uh 90 degrees plus 180 degrees. No, if you're not going to use the tree graph, you can also use the, what you call the cast diagram. Let's use a cast diagram. I think that's what you are using, not tree graphs. We didn't do tree graphs as yet. One second. Let's take tree graphs out. Let's use a cast diagram. So just think of cos as being 0. 0, just take 0 as positive, right? Now, where is cos positive? Is positive in the fourth quadrant and is positive in the first quadrant, right? So 90 degrees. 90 degrees plus plus 360. Cos of 90 is 0. 90 plus 360k. Yeah, that should suffice. So x is now equal to 45 degrees plus 180 degrees k. Are we good? X is equal to 45 plus 180k. 2x is equal to 90 degrees plus 3. Okay, let's substitute some values and check. Take your calculator out and let's substitute values and check. Oh yes, sorry, we need two general solutions here, right? So what I have done here is we have just solved a general solution for the first quadrant, right? This was quadrant 1 general solution. And what about quadrant 4? You have to take the, you have to minus the reference angle. So 2x is equal to 360 minus the reference angle, which is 90, right? Plus, plus 360k, where k is an element of integers. So x is now equal to 360 minus 90 is 270. 270 divided by 2 is 135. Yeah, I think it's 135. Remember, we're dividing it by 2. That's 270 plus 180 degrees k. 135 plus, so this was 45 plus 180k, and this is 135 plus 180 degrees k. Yeah, so those are your two answers. For these values of x, that will become undefined. And this one is easy because cos x equals sin x. We only have one general solution because it's tan, okay? We're going to convert it to tan when you have sine and cos mixture. So you're just going to say sin x is equal to cos x, divide both sides by cos, right? So you got tan x is equal to tan of x is equal to 1. Reference angle is 45, okay? So just 45 plus, so x is equal to 45 degrees plus K 180 or 180K. Where is tan positive? First quadrant, okay? For the second part. We don't need to look at third and fourth quadrant because the solutions will overlap. So 45 degrees plus 180 degrees K, because the period of tan is 180. All right. Yeah. So those are your three general solutions. Yeah, that should be good. Next. So that's undefined. What does undefined mean? Set the denominator equal to 0 and solve the denominator for the different values of x. Now let's look at more. We're going into trigonometric equations now, right? So this was just example number 22, 23, 24. Right. Example number 25. So we want to solve these trigonometric equations where we have, so we will solve trigonometric equations involving tan, co-ratios, and quadratics, right? So we have 4 cos x equals negative 3 sine x. So because I have cos on one side and sine on the other side, I can just divide both sides by cos and make it tan. So I've got 4 is equal to negative 3 tan x because sine over cos is tan. So now I can say this implies tan x is equal to negative 4 over 3. Now remember, tan is negative in the second quadrant, especially for tan. Whenever we are solving tan trigonometric equation, we don't look at third and fourth quadrant because the solutions overlap. Okay, so you only need one general solution for tan. Only for sine and cos, there's always two. Now we got negative 4 over 3. So to find the reference angle will be tan inverse 4 over 3, not negative, because the negative tells us which quadrant should we go in. We should go in the second quadrant, right? So we are working with the second quadrant. That's where the negative is. So tan inverse 4 over 3, we're going to put that into the calculator and see shift tan 4 over 3. And I would see what the answer is. 53,13 degrees, right? So my answer is x equals, which quadrant is the tan in? In the second quadrant. So second quadrant is 180 minus, this is 180 minus the reference angle theta. And this is 180 plus reference angle. That's 360 minus reference angle, right? And this is just adding the reference angle. So we're not in the first quadrant, we're in the second quadrant. So take 180 minus the reference angle. So 180 minus the reference angle, which is 53,13 degrees, plus K 180 or 180K, because the period of tan is 180. Now that's it. That's all you need to do, because there's only one general solution for tan. So 180 minus the answer, we're getting 126,87 plus 180 degrees K, whichever way you like to write it. Okay, that's the only answer. Please don't waste your time doing the fourth quadrant general solution. It's not required. If you do it, it's fine. You will find that when you are finding specific solution, you only need to use one of them. So only one general solution for tan. Okay. Okay, and the next one, we got cos 3x is equal to sine 2x. Very important one. So what was the first one? We used a tan general solution. Next one, we are using co-ratios to solve. Now, it's up to you how you want to change it, all right? You can either change the sine into a cos, or you can change the cos into a sine. First of all, this is 3x and this is 2x. The angles are way different, so I can't change into tan, okay? Because it's not the same angle. You can only change into tan if it's the same angle, see? Then you can change into tan. I cannot change this equation into tan at all. So what we use, a technique called co-ratio. Now, what is co-ratio? We know that cos of 90 minus theta, or just say cos of 90 minus angle. Cos of 90 minus the angle is what? Sine of the angle, right? And sine of 90 minus the angle is sine of the angle, or is cos of the angle. So you know that. That's what we're going to do. We're going to change the sine into a cos. So cos 3x is equal to cos 90 minus the x. See, I changed it. Now, if you try to simplify the cos of 90 minus the angle, you will get sine of the angle. So it works. Okay, the co-ratio works. Now, what's important here is that you don't only get one of them, you get two of these. Okay, so that's the reason why I showed you. So what solution is this? Where is the solution that you are working? You're working with 90 minus angle. Now, because you are doing co-ratio, you are using a vertical reduction. You're trying to reduce on the vertical line. So you are using 90 and 270 on the cast diagram. And what did I tell you about sine and cos? Sine or cos has two general solutions. Tan only has one. Now, you got cos and you change the other side to cos. But now you said, why did you change it into cos of 90 minus 2x? Because you saw that the sign over here was positive. You saw that cos is positive. Cos is positive in the first quadrant and in the fourth quadrant, but we need to use 90 minus, all right? Cos is positive. That's the reason why the sign goes in the first and the fourth quadrant. Now, I'm doing quadrant 1 solution here, quadrant 1. So cos 3x is equal to cos of 90 minus 2x, which is sine 2x. It works. So my first quadrant solution is done. So now how do we solve this? We drop the cos on both sides and we just add K360 onto the other side. So we say 3x is equal to 90 minus 2x plus K360. Now solve for x. Bring that over, you get 5x is equal to 90 minus 90 plus K360. Don't forget, right, K is an element of Z. Right, continue. We divide everything by 5. So x is equal to 18 degrees plus 360 divided by 5. I think you can get 72. Right, so this is only one general solution, okay? This is only one general solution. So where's your second general solution? In the fourth quadrant. In the fourth quadrant, you're going to write down cos 3x because I'm changing the sign into a cos is equal to cos. Cos of what? 270 plus. Okay, because you are using co-ratios. If you are using co-ratios, you have to use 90 and 270. So 270 plus 2x. Now, why did I use? Let's check if cos of 270 plus 2x is actually sine x. All right. Cos of 270 plus 2x. So 270 plus 2x is in the fourth quadrant. Cos is positive and cos changes to sine because of 270. So sine 2x. Yeah, so it works. It reduces to sine 2x. Now I can drop the cos on both sides. I've got 3x is equal to 270 plus 2x plus a 360. Now we're done. Just take the 2x over, you just get x. 3x minus 2x is x. So 270 plus K360. Any questions, guys? Now I'm going to pose one question to you. What if there was a negative there? What if cos 3x, additional question, cos 3x was equal to negative sine 2x. Now what you're going to do? You're going to draw the cos diagram. Now ask yourself the question, all right, where is cos negative? Cos is negative in the second quadrant and in the third quadrant, and I have to use 90 and 270. So how will you go and do this? Your second quadrant, will be cos 3x will be equal to cos 90 plus 2x. And you know how to solve this now. Drop the cos and add 360 and K360 and solve. And your third quadrant 3 solution will be cos 3x is equal to cos of 270 minus 2x, 270 minus the reference angle, because you are only using 90 and 270 to reduce. We are using co-ratios, don't forget. Right, so that's how you're going to solve that. And now you know how to solve this as well. Drop the cos and add K360 and continue from there. Easy. Let's look at the next problem. So what did we do so far? If we have sine and cos mixture, right? And we have sine, if we can take sine on one side and cos on one side with the same angle, then yes. Now, if you have sine and cos mixture with different angles, okay, but no values in the front, you have different angles, then use co-ratios. Now, this one, what do we do here? We use something called a quadratic. It looks like a quadratic form, but it looks like a quadratic form, but we have a cos 2x, cos x there. So what we're going to do is change everything in terms of cos x. So we're going to change the sine squared x into cos x. So we got 2. What is sine squared x? 1 minus cos squared x minus cos x minus 2 is equal to 0. So you got 2 minus 2 cos squared x minus cos x minus 2 is equal to 0. Looks like 2 and minus 2 cancels out. Yes, it does. Multiply everything by negative. Right, so you got 2 cos squared x plus cos x is equal to 0. Right? So take out cos x as a common factor, and you're left with 2 cos x plus 1 is equal to 0. Right, so far, so good. Just remember, the starting point is very important. If you can't do that, then you will be lost. Then you can't solve you won't be able to get the correct answers. Now, let's continue. So either cos x is equal to 0, or either 2 cos x or cos x is equal to negative half, right? I don't need to write 2 cos x plus 1 is equal to 0. I'm solving for cos x, right? So either cos x is equal to negative half. Let's solve this part first. So when is cos negative? Reference angle is 60 degrees. It's a special angle, right? And when is cos negative? Cos is negative in the second and third quadrant. We can only use 180, right? So 180 minus 180 plus. So x is equal to 180 minus 60, which is 120 plus K360, or 180 plus 60, which is 240 plus K360. K is an element of Z, integers. What about this one? Cos x is equal to 0. A reference angle is when cos of 90 is 0, right? So you're going to say x is equal to first quadrant 90 plus K360, or fourth quadrant cos is positive. So x is equal to 270. Why? Because 360 minus 90, 360 minus the reference angle is 270 plus K360. But I think you see in this case, we can go and combine because it's saying it's 0. So you can just, if you're using trig graphs, then that's what I wanted to show you. If you are using trig graphs, then you can just combine them, because every 180 degrees you will get a 0. So you can just write x is equal to 90 degrees plus 180 degrees K. But if you don't want to write this, you can just use a cast diagram. This is from cast diagrams. You'll end up with 4th solution. If you combine these two, then you will get this answer, 90 plus 180K, right? So you either you write down those 4 using the cast diagram only. But if you're going to use trig graphs, then it's easier to write down 90 plus 180K. Okay. So that's great, guys. Let's look at the next one. We got 2 cos squared x minus sine x plus 1 is equal to 0. We also want to solve this one, all right? So now we're going to put the equation in terms of sine only. So what is cos squared x? 2 into 1 minus sine squared x. Minus sine x plus 1 is equal to 0. Yes, you have a question? Anyone has a question? All right, so we good. So we have 2 minus 2 sine squared x minus sine x plus 1 is equal to 0. So nothing cancels out here. It looks like a proper quadratic. So we're going to multiply 2 plus 1 is 3. Multiply by negative, you'll get negative 3. Multiply this by negative, you get 2 sine squared x. Remember, I added the 2 and the 1. It was 3. So now it became negative 3 because remember, I can't have negatives in the in front of the quadratic. I'm trying to write it in the standard form. The standard form of the quadratic is ax squared plus bx plus c. Now, when you're solving equation, make sure the value of a is always positive. Okay? By multiplying, if it is negative, multiply by a negative. So that's what we are doing. So plus sine x. Right, so I've changed all the signs. Now you have to factorize like normal. So that's 2 sine x, right? And sine x. 2 sine x and sine x. I think the 3 goes here and the 1 will go here. No, the other way around. The 3 will go here and the 1 will go here. Why I can't put the 3 there? Because when I'm multiplying the 2 and the 3, I'm getting 6 sine x. But I only want plus 1 sine x in the center. So 2 times 1 is 2 sine x plus 3 sine x. So minus must go here. So minus 2 sine x plus 3 sine x is plus 1 sine x. 3 times the negative 1 is negative 3. So now problem solved. We got sine x is equal to negative 3 over 2, or sine of x is equal to 1. Now this is very important because sine of x is equal to negative 3 over 2. So if you try shift sine 3 over 2, you see you get math error, which means that you're going to write not applicable, right? You can't solve this because remember the range of sine can only be between minus 1 and 1. You know the sine graph, because sine x can only be between minus 1 and 1. That's the reason why you can't solve this, okay? You can't solve this equation. Sine of x can never ever be negative 3 over 2. But sine of x can be equal to 1. Now, when is the sine of x equal to 1? That's a cos graph, sorry. At 90 degrees, all right? Sine of x is equal to 1 at 90 degrees. And the next point will be from here to there. So that's 90 and then 270 interval. So anyways, we are not going to use the trig graph because if you're going to use the trig graph, you're going to say 90 degrees plus 270k. But we don't do that combining the solutions. So what we're going to do is I'm just going to solve two general solutions for you, okay? So we take sine of x is equal to 1. When is it positive? So we take 1 as positive. Yeah, we have to take 1 as positive. It is positive. When is sine positive? In the first quadrant and the second quadrant. So quadrant 1 solution, reference angle is equal to 90 degrees. Sine of 90 is 1. So x is equal to 90 degrees plus K360. That's my quadrant 1 solution. Or x is equal to 180. 180 minus 90 is also 90. 180 minus 90 is also 90 plus K360. Right, so which is 90 degrees plus K360. So you only get one solution because the reason why you only get one solution is because it's occurring at the maximum point, right? So you're only going to take that general solution. That's your general solution, okay? you need to write down K is an element of Z somewhere along the line. So you only had one answer because you see both the answers overlap. So just take one answer. That one you can, no use writing that out again, right? So only one general solution. Right, great. Next. Oh yes, I have lots and lots of questions. Now we're going to move on to double and compound angle identities, right? How do I use double angles and how do I use compound angles in identities? This is very important. Right, so we got sine 2 alpha plus 2 sine alpha is equal to 0. Now, because I have a double angle here, remember, first of all, the angles are different, right? So, and the angle is double angle. So the double angle for sine 2a is just one of them, 2 sine alpha, cos alpha, plus 2 sine alpha is equal to 0. You can take out 2 sine alpha as a common factor or get rid of the 2 completely because you're dividing everything by 2. Okay, that's the reason why the 2 cancels out. Because 0 divided by 2 is 0 as well. So now take a sine alpha as a common factor. You're left with cos alpha plus 1. So sine alpha cos alpha plus sine alpha is equal to 0. So you got sine alpha is equal to 0 or cos alpha is equal to -1. Now, when is sine 0? So cast diagram. Let's move this to the side. The cast diagram here, right? So when is take 0 as positive, right? So sine is positive in the first and second quadrant. So sine of what is 0? So reference angle is 0. Sine of 0 is 0, right? So alpha is equal to 0 degrees plus K360. Or alpha is equal to 180 minus 0, which is 180 plus K360. So this side is done. Now next one. When is cos negative? Cos is negative in the second and third quadrant, okay? So reference angle is cos inverse 1, which is 90 degrees. Second quadrant means 180 minus. So alpha is equal to 180 minus 90, which is 90 plus K360. Or third quadrant means 180 plus 90, which is 270 plus K360. So these are your 4 general solutions using the cast diagram only. I didn't use trig graphs here because you can also kind of like combine these two solutions. Right, so these are your 4 general solutions. Don't forget to write K is an element of integers. Great. Yeah, so we're doing fine so far. Yes, next question. Question number 30. So what we have here is we have 2 sine 2 theta minus 3 cos theta. We want to find the general solution. All right, we want to solve this trigonometric equation. Now, the problem is we have different angles, so it clearly can't be tan. It's not a tan, all right? Because the angles are different. If the angles were the same, there was no 2 here, you convert to tan and easy peasy. Now, because the angles are different, we have to change the sine 2 theta. We need to replace that with the double angle. So that is 2 sine theta cos theta is equal to 3 cos theta is equal to, actually bring the 3 cos theta to the other side and make it equal to 0. Okay, I brought this over to the other side and I open this up and make it equal to 0. So now what we have is 4 sine theta. So again, we can drop the 2's because we are dividing it by 2. Divide by 2, divide by 2, that can cancel out. Now you can just take out cos theta as a common factor. And we left with 2 sine theta minus 1 is equal to 0. So now we have cos theta is equal to 0, or sine theta is equal to half. Now continue solving. We are going to use the cast diagram to solve. Take cos as positive. Sorry, take 0 as positive. So cos is positive in the first quadrant and fourth quadrant. Remember, fourth quadrant is 360 minus. So a reference angle is cos of what is 0? Cos of 0, cos of 90 is 0, 90 degrees. So we have theta is equal to first quadrant solution is 90 degrees plus K360, or our fourth quadrant solution will be 360 minus 90, which is 270 plus K360. Over here, reference angle is half, is a special angle, right? So reference angle is 30 degrees, sine of 30 is half, where sine positive. Sine is positive in the first and second quadrant. So first quadrant solution is here. Theta is equal to 30 degrees plus K360, or theta is equal to 180 minus 30, which is 150 plus K360. Because remember, sine of 30 is half and sine of 150 is also half, right? So easy peasy, that's also done. Let's look at the last problem. Question number 31. In question number 31, what we have here, in question 31, 1 plus sine 2x minus 4 sine squared x is equal to 0. It does look like a quadratic, okay? But we have a problem because in this quadratic, we got sine squared x. The angles are different in this quadratic, okay? So you got 1 plus, so we need to change the sine 2x into 2 sine x cos x. But now if you change the sine 2x into 2 sine x cos x, you got a bigger problem. And what's the bigger problem? The problem is the 1. Okay, because now you got cos in the expansion of sine 2x. So you need to change the 1 and the sine 2x in terms of sine and cos. So what is 1? Sine squared plus cos squared. All right, and the sine 2x is plus 2 sine x cos x. We don't have an option, that's just a double angle, right? And then we got minus 4 sine squared x is equal to 0. I hope you understood that, right? The reason why we change the 1 is because when we expand the sine 2x double angle, we get cos, and you got sine squared here. So that's the problem. Because the cos is causing a problem, we have to expand the 1 in terms of sine squared and cos squared, right? Now we can make a quadratic, right? So how are we going to make a quadratic? Let's bring the minus 4 sine squared x right in the front. Now remember, minus 4 sine squared x plus sine squared x is minus 3 sine squared x. The middle term can remain as plus 2 sine x cos x. And the last term can be plus cos squared x. So what did we do here? The only thing that we did was sine squared and minus 4 sine squared. We combined those because those are like terms. Write it in standard form. So 3 sine squared x minus 2 sine x cos x minus cos squared x is equal to 0. So you can see you got a double angle and an identity substitution, and you're making a quadratic out of this. So now let's see. So to get 3 sine squared x, it has to be 3 sine x multiplied by sine x. Okay. And now we need to figure out with the cos x. There's only one way you can get cos x, which is cos x times cos x. There's only one way you can get cos squared x. So now we need to figure out which one is minus, which one is a plus. So that one will be a minus because that will give me minus 3, and this one should be a plus. Minus 3 sine x cos x plus 1 sine x cos x will give me minus 2. Now solving this will give me 3 sine x plus cos x is equal to 0. Or better, make 3 sine x is equal to negative cos x. 3 sine x is equal to negative cos x, or sin x is equal to cos x, or sin x, and see how neat this worked out. Sin x is equal to cos x, because now we can divide both sides. Now we got the same angles. So lovely. Now we can we can reduce to tan. So divide by cos x, divide by cos x. So we got 3 tan x is equal to negative 1. So divide by 3. Tan x is equal to negative 1/3. And you can do the same on this side. Divided by sin x and divide by sin x. So you got tan x, sine over cos is divide by cos x, sorry. We're dividing it by cos x, dividing it by cos x. Cos divided by cos is 1. Now, we said there's only one general solution for tan, right? Because we don't work with third and fourth quadrants. So tan x is equal to negative 1/3. So tan is negative in the second quadrant and positive in the first quadrant, okay? So on this side, we got reference angle, which is tan inverse 1/3. What is tan inverse 1/3? Mishka, you there? You understanding?
Yes,
18,43. We're getting 18,43 degrees. So x is equal to, which quadrant is the tan in? Is in the second quadrant. So 180 minus 18,43 degrees plus not K360, be careful, K180 is tan. And we can take 180 minus 18,43, 180 minus answer 161,57 plus K180. And this one is easy because where's tan positive? First quadrant, a reference angle is just 45 degrees. So it's easy. X is equal to 45 degrees plus K180. How we know this? Tan of 45 is 1. It's a special angle. Right, so these are your two general solution. Okay. Don't forget to write K is an element of Z. You can just underline it and say, okay, these are my two general solutions. That's one and this one here, simplified. Right, great. So what did we use so far? We are using double angles, right? We use a double angle here. I didn't get a double angle with it was only sine. There was no cos double angle. Okay, we might have in other problems. Look at this example here now. Example number 32. We got cos x minus sin x minus root 2 is equal to 0. Imagine if it was just cos x minus sin x is equal to 0. That would have been nice. But now that root 2 is a big problem. Okay? And sin x and cos x is already in simplified form. So what am I supposed to do here now? All right. So what we're going to do first is we're going to take the root 2 over and write down cos x. Obviously, there is no double angles, right? There's no reducing, there's no quadratic. So all your options are over. So the only thing that you are left with is a compound angle. That's the only thing you're left with. You are running out of options here. So what option you have left? You have an option of compound angle. So you're going to write down cos x minus sin x is equal to square root of 2. Now there's a reason why I left this. What we're going to do here is we're going to divide everything by square root of 2, okay? Or multiply it by 1 over root 2. See how difficult this problem is to think about. So if you multiply everything, both sides of the equation by 1 over root 2, you'll get 1 here. Root 2 times 1 over root 2 is 1. Take cos x multiplied by 1 over root 2 sin x multiplied by 1 over root 2. Why did I do that? Because that gave us an indication of what to multiply by. Now, what we are going to do is change the 1 over root 2 into cos of 45. Okay, isn't cos 45 is 1 over root 2? And change the 1 over root 2 here into sine 45. Now you see a pattern. Cos cos minus sine sine. What is that? That is a compound angle for cos. So that is cos x plus 45, which is equals to 1. And see how nicely this simplified. Cos cos minus sine sine. There's a first angle, there's a second angle. Just adding those two angles, right? And that's an expansion for cos here. So what's the reference angle now? Now we're solving a general solution. Where is cos positive? 1 is positive, cos is positive in first quadrant and the fourth quadrant. So now a reference angle, cos of what is 1? Cos inverse 1 is 90 degrees. So no, 0, 0, 0, 0. Keep on confusing it with sign. All right, so 0 degrees. Cos of 0 is 1. Now, what is your reference? We're taking quadrant 1 solution, okay? My solution in quadrant 1, reference angle is x plus 45. So I'm going to write that down here. The angle is 0, first quadrant, plus k 360, right? So x is equal to negative 45 plus k 360. So this is one answer done. Now, what is quadrant 4 solution? The reference angle is x plus 45. X plus 45 is equal to 360 minus 0. So just 360 plus k 360. Now you take 360 minus 45, you'll get 315 plus k 360. That's what x is. So those are your two general solutions, okay? When you're doing trig graphs, then I'll show you how to combine these. Okay, so for now, you can just write down this answer and that answer we good because we are only using the cast diagram. Okay, so I hope you guys are understanding all this. Now, we have enough knowledge and information, right, to solve some past paper problems. I've compiled something with all the different 9 provinces from last year, trial papers. So we're going to work with that. Let's look at this. What is this? Western Cape paper, right? So I'm calling it question number 33, but in the paper itself is question 5.3. Let's see how this is working out. So we are given cos of a plus 45 is cos a minus sine a over root 2. Prove this identity. It's easy to prove it. How? We're going to say left-hand side is equal to cos a cos 45. We're expanding cos a plus 45 minus sine a sine 45. We kind of just did this problem now. So you got cos a times 1 over root 2 minus sine a times 1 over root 2. So what do we have? You got root 2 in the denominator. So cos a minus sine a all over root 2. So it works out cos a minus sine a all over square root of 2, which is RHS. Easy peasy. Right, moving on to the next question. Hence, so otherwise solve for a if cos a minus sine a is equal to 1 over root 2. What they said, if cos a minus sine a is equal to 1 over root 2. cos A minus sine A is equal to 1 over root 2. If they told us this, right? We know that cos A minus sine A is equal to 1 over root 2. What was the original sum here? The original problem here was this, okay? Cos A minus sine A is equal to 1 over root 2. This part is 1 over root 2. Okay, yeah, so we need to solve for A. So take the original, because they said hence, use the answer above, right? Because they said hence, use the identity above to solve. So we're going to leave cos A plus 45 is equal to, what's cos A minus sine A? They're telling us that is 1 over root 2, right? And we're still dividing it by root 2. So 1 over root 2 divided by root 2 is 1 over root 2 times 1 over root 2, right? So we change this. So it's just basically half. If you're going to do some calculations there, or just use a calculator, you should get to that stage. So cos A plus 45 degrees is equal to half, okay? A reference angle is cos of what is half? 60 degrees. Now, where is cos positive? Cos is positive in first and fourth quadrant. So quadrant 1 solution is A plus 45. What's the reference angle? A plus 45 is equal to 60 degrees plus K 360. No, but we only want an answer between 0 and 90, so no fourth quadrant, right? So read the question carefully. We don't need to find a general solution and stuff. We only wanted the answer in the first quadrant. So why am I doing this? I didn't read the problem. All right, so we only want an answer between 0 and 90. So in the first quadrant, cos is positive. So just A plus 45 is equal to 60 degrees, all right? Cos inverse half, which is 60. So A is equal to 15 degrees. That's it, right? So that's your answer for A. Look at the next question. They ask for the general solution, okay? And look at this general solution, how it is structured. I hope it's not that difficult. Let's see. 2 sine x times cos x minus 0, 0,8 is equal to 0. Okay. So what's the trick here is that you see that you have a 2 sine x cos x, right? They should have made this a little bit more difficult. They should have said sine x cos x minus 0, 4 is equal to 0. Then you multiply by 2 and then you change this into 2 sine x cos x. But anyways, 2 sine x cos x is what? Reduce this. This is the expanded form of the double angle. So it's going to be the contracted form. Sine 2x. And take this negative 0, 0,8 to the other side, which is 0, 0,8. Now, where is sine positive? Sine is positive in the first and second quadrant. So 180 minus and the reference angle itself. So I'm getting a reference angle which is sine inverse 0, 0,8. Shift sine 0 0.8. 53,13. Right. So now quadrant 1 solution is here. 2x is equal to 53,13 plus K360. X is equal to 53,13, sorry. Should be a 13, not 15. We need to take 53,13 and divide it by 2, 26,57 plus K180. Or quadrant 2 solution. Reference angle is 2x. 180 minus 53,13 plus K 360. Don't forget to write K is an element of integers. Anyways, X is now equal to 180 minus this. 180 minus 2 times answer divided by 2. If you do all that, you will get 63,43 plus. If you take this, 180 minus 53.13. Let me just double check that. Yeah, it looks right. 63,43 plus K 180. Okay, and those are your two answers. The general solution, that's what they wanted. They wanted the general solution for that problem. Right. Next problem. Look at the types of problems that's given here. Look at this from the same Western Cape paper. Prove that this part over here is non-real for any real value of m. It's like mixing it up with paper 2 or paper 1. When when are the values non-real in this case? The values are non-real when everything under the square root is less than 0. So you need to solve this inequality. Cos squared, negative cos squared, 90 degrees minus m is less than 0. Then it will be non-real for any real value of m. Right, so first we're going to make it equal to 0, and then we're going to see what to do. Or so that's what we are solving. Prove that this part here is non-real for any real value of m. So they can take any value of m. I think we should simplify this first, okay? Let me try to simplify this. Let's simplify everything under the square root. So this expression here is equal to negative 90 minus m, all right? That's already a co-ratio, cos of 90 minus m. So that will become negative sine squared. Negative sine squared m minus cos squared m, because cos of negative angle is cos positive. So let's write cos m times cos m. Negative sine squared m. For any real value of m. What if the value of m is 0? Of 90 is 0. Is non-real. Okay, negative sine squared m. We can't really simplify this because negative sine squared m is still left with a negative. But you want to prove that it is non-real. So remember the square root of, I'll give you an example, square root of negative 25. You can take the 25 out. It's the same thing as saying square root of negative 1 times 25, okay? And you can take the 25 out. That's 5 square root of negative 1. So the square root of sine squared m, right? You can take the sine squared m out. You can say that is sine m times square root of negative 1 negative cos squared m. Negative cos squared m. So you can say this expression here, no matter what the value of m is, no matter what the value of m is, this entire expression here is non-real. You can see this part is a non-real part. Say square root of negative 1 is non-real. This implies the entire expression, the entire expression is non-real for any angle M. Okay, for any real value of M. For any M is an element of real numbers. Are we good? Make sense? No matter what the value of M is, that entire expression will always be non-real. So it makes this entire expression non-real as well. So you just needed to solve that first part. Nice question. Right, moving on to the next few parts. Let's see. This was a Northern Province question. Look at this. Prove the identity. So we say left-hand side is equal to sine 2 theta. You see, you have a double angle here. You need to think about what you need to do here, right? Because you got a cos cubed, you got a cos theta, and you got a sine 2 theta here. Why do we have a cos cubed? Maybe we can take a 2 cos theta as a common factor out here. That's the reason why we got a cos cubed. Look at this. We can group that, and we can take a 2 cos theta out as a common factor. So you can get some kind of an identity there. And this one here, sine 2 theta, we don't have an option. So let's write that down. No, but what they're saying here is that this whole thing must be equal to sine 2 theta. How? Okay. Sine 2 theta. Okay, let's take out sine 2 theta. Sine 2 theta, let's expand that because it's a double angle. Sine 2 theta is 2 sine theta cos theta plus, we said for the second two terms on the numerator, we're going to factorize. And we will be left with 1 minus cosine squared. Isn't? Because remember, I'm taking out 2 cos theta out. So you're left with cos theta times cos theta, which is cos squared theta divided by 1 plus sine theta. Now, we got 2 sine theta cos theta plus 2 cos theta. And what do you have here? We have sine squared theta. Right, so great. We have an identity that we can simplify. And we left to the 1 plus sine theta. Now, clearly, 1 plus sine theta from the bottom needs to cancel out somehow. So let's try to cancel this out with the top. So we can take out 2 sine theta as a common factor. See, there's the 2 here. And you got a sine theta there. Take it out as a common factor. Oh, no, you can take out 2 sine theta cos theta out as a common factor. All right, so now you are left with 1 plus sine theta. Obviously, because the bottom needs to cancel out, we're kind of cheating here. So 2 sine theta cos theta times 1 is that. And then you got 2 sine squared theta cos theta. I have to open it up to check if I'm getting the terms on the top. Yes, I am. And then dividing it by 1 plus sine theta. Now guess what? 1 plus sine theta, 1 plus sine theta cancels out. And 2 sine theta cos theta is back to double angle. Here's sine 2 theta, which is RHS. Great. Okay, so we kind of use this to factorize. So you couldn't have just done anything over there in the last two terms. You had to use all the 3 terms to simplify that. Right, so that was a nice question. Now, this question is just 1 mark or 2 marks because we only have a single fraction. When will this identity, what values of theta in the interval minus 360 to 360 is the identity in question undefined. When is it undefined? When 1 plus sine theta is equal to 0. When 1 plus sine theta is equal to 0, then it is undefined. Now, sine theta is equal to -1. Let's look, if you know the sine graph, it will be way easier to solve this, right? Because it's from a trial paper, you should have known the sine graph. So I'm just going to use the sine graph. It would have been much more easier to solve this because you can just write down all the values of theta. And when this graph sine theta hits -1. Right, so that's the sine graph. When is it -1? At -90 and at 270. That's when the sine graph is at -1. And so there's only two answers. Theta equals -90. Theta equals -90 degrees, or theta is equal to 270 degrees. That's it. That's when the sine graph is -1. We only want -1, not +1. Right, so great. That's the reason why it was 2 marks. You could have just wrote down the two answers and get the 2 marks. Ooh, next question. Calculate the maximum value of this expression. Now, problem is, look at the cos graph. Remember, the cos graph has a minimum and maximum value, right? So what's the range for cos? From -1 to 1. I'm going to substitute both the values because I want the maximum value of this expression, not the maximum value of cos x of the expression. So I don't know whether it's min or max. So I'm going to say value 1 is 4 over 2 minus 1, because I took the -1 from here and put it in there. So I've got 4 over 3. And my second value is equal to value 2 is putting the 1 here. No, sorry. There was a plus here, man. It's plus -1. So it's going to be 4. Okay. 4 divided by -1. 4 divided by 1. And this is 4 over 2 plus 1, which is 4 over 3. So now imagine the maximum value of this is actually 4. So what you're going to say? Max value is equal to 4, not 4 over 3. And the maximum value occurs at -1. Okay? Because that's a range of cos. You have to work out both the values and look at the endpoints of the cos graph, the highest point and the, remember, cos x is an element of -1 to 1. So you need to look at the minimum and the maximum. You need to look at the endpoints of the cos graph, the highest point, the peaks, the highest point and the lowest point. Substitute it and see which value gives you. It's not the maximum and the minimum of cos x, it's the maximum value of this entire expression. That's the reason why the maximum value is 4. And these types of questions are also in the NBTs. Let's look at another paper. This is from the Northern Cape trials. What was this? This was Northwest province, right? Again, question 1, they're asking for general solution, right? Arnav, you there? You understanding? Okay, let's
Yes.
have a look at this general solution here. We want to find the general solution. Now we got a cos 2x and we got a sin x. We can't do anything with the sin x here. We got a cos 2x here. Okay. So what should you expand the cos 2x in terms of? I told you we got a sin x on this side, okay? Let's bring the formulas down. Right, so these are the formulas that we have. And I think about what you need to do. Which one should I use? I told you, I gave you a hint. Uh, I said we got sin x on this side and we got cos 2x here. So expand the cos 2x in terms of sin x only, right? So we're going to choose the last one, last option, right? So we're going to say this is sin x is equal to 1 minus, what is cos 2x? 1 minus 2 sine squared x. 1 minus 1 cancels out. 1 minus 1 cancels out. You're left with minus and minus 2 sine squared x. Let's bring the sine x over. Minus sine x and make it equal to 0 on the other side. It is equal to 0 because I'm bringing the sine x over to the other side, okay? So let's take out the equal to 0 here, put the equal to 0 onto the other side. So what's happening now? 1 and minus 1 cancels out. We can take out sine x as a common factor. We have to 2 sine x minus 1 is equal to 0. So sine x is equal to 0, or sine x is equal to half. This is easy. We are using cos diagram to solve this. So sine of 30 is half. Reference angle is equal to 30 degrees. First quadrant and second quadrant, right? Same here. 0 is positive, first and second quadrant. So x is equal to 30 degrees plus k 360, or x is equal to 150, 180 minus 30, k 360. K is an element of integers. Same here. X is equal to 0 degrees plus k 360, or x is equal to 180 plus k 360. So you kind of have like 1, 2, 3, 4. Just take out 0 degrees, right? You don't need to write 0 degrees. So just k 360 degrees. Okay. And these are my 4 general solutions. Next question. Consider the identity sine A plus B plus sine A minus B is equal to 2 sine A cos B. How? 2 sine A cos B. It's not 2 sine A sine B. Be careful. The angles are different, okay? Don't get carried away. This is not sine 2A, by the way. Prove the identity. It's easy to prove. Just open up the left-hand side. Left-hand side is equal to sine A, sine B, sine A, cos B, sine cos cos sine, cos B plus cos A sine B plus, it's going to be the same thing with a minus, right? It's going to be the same thing, but with a minus. So I'm just going to copy and paste. It's the same thing, just has a minus there. Just take this out. Yep. Now you can clearly see there's something that's going to cancel out. Sine A cos B. Something must cancel out here. Yeah, this cancels out. because it's opposite sign. That one and that one is out. And now you got sine A cos B plus sine A cos B. I'm saying that twice. So there's 2 sine A cos B, which is equals to RHS. So I put the identity. Next, hence or otherwise. The next question. Uh, Hence or otherwise show without using calculator that sine 7x plus sine 3x is equal to tan 5x over the second fraction cos 7x plus cos 3x is equal to tan 5x. How? Sure, we need to think about this. Hence, because they said hence, must use the above thing. Tan 5x. Look, we had sine, and we got cos. So I'm sure we can break this up. Sine. Okay, look at the 7x. We're gonna break the 7x up into a plus b, and the sine x up into the 3x up into a plus b. So we need to say left hand side is equal to. So now we need to say a plus b is equal to 7x, right? And we need to say a minus b is equal to 3x. Okay. So I need to solve for a. So I'm going to get 2a is equal to 10x. So a is equal to 5x. So if a is 5x, what is b? B is equal to 2x. So now break up the 7x as sine 5x plus 2x, and break the 3x up as a minus b, sine 5x minus 2x. And do the same at the bottom. Cos 5x plus 2x plus cos 5x minus 2x. But now we already know that the top is 2 sine A cos B. No need to expand the whole thing out, right? So we already know that that is 2 sine A. What is A? 5x cos 2x. B is 2x. But the bottom is, we didn't prove anything at the bottom of the cos. So what are we supposed to do with the bottom? Because we don't have a formula. So that's where you need to use a formula to expand the bottom as well. To expand the bottom, you have to use the cosine rule. You're going to have cos 5x cos 2x minus sine 5x sine 2x. I'm going to continue here, plus cos 5x cos 2x plus sine 5x sine 2x. So you can clearly see even in this part of here, that and that cancels out. So you're just left with 2 sine 5x cos 2x, and the denominator you left with 2. There's 2 of those, all right? 2 cos 5x cos 2x. And guess what? The cos 2x and the cos 2x cancel out. And this was a nice challenging problem. So you can clearly see the cos 2x and the cos 2x cancel out. And you got and then you got the 2's canceling out, and then you got sine 5x over cos 5x, which is just basically equals to tan 5x, which is right hand side. Very nice problem. Tan 5x, which is equals to right hand side. Nice. And that's proved. Right, no more questions there. Let's look at Mpumalanga and then KwaZulu-Natal, and then I think we can end off there. Again, prove the identity. You can see it has like a set format. IEB has like similar types of questions as well, right? You have all the knowledge to do the IEB questions. Next one. Look at this. So we want to simplify this entire thing to sine theta. Okay, how? Okay, what we can see here is that we have a double angle and we have a negative. So the negative can just go to the front, right? Because it's in the fourth quadrant. And sine 2 theta can become 2 sine theta cos theta. And see the way that the second part is written. Look at the way that this part here is written. Yes. The way that this part is written, should we simplify? No, but we already got sine and cos mixture here. Because we have a sine and cos mixture here, we have a cos squared there. We should expand the 1 in terms of sine and cos. I was actually going to take 1 minus cos squared theta and make it sine squared theta. Will that help us? Yes, it can. Look at this. Yes, that will actually help us. This is 1 minus cos squared is sine squared theta. All right, divided by sine theta minus 2 cos theta minus 2 cos theta, which is take out sine theta as a common factor on top. And what are you left with on top now? If you take out sine theta as a common factor, you're left with minus 2 cos theta plus sine theta, which is identical to the bottom part. Minus 2 cos theta, which is basically identical to the bottom, and that cancels out. And it becomes sine theta, which is RHS. So I hope you understood that. Very simple identity. It's just that you need to figure out the second part, supposed to be the second part was supposed to be 1 minus cosine squared, which is sine squared. If you went and expanded the one in terms of sine squared and cosine squared, then you will end up using a trinomial and solving. But that will work a little bit more difficult. I wouldn't suggest that. Now, again, they're asking for undefined. Determine the values of theta for which the identity will be undefined. When will the identity be undefined? When the denominator only is equal to 0. Sine theta minus 2 cosine theta is equal to 0. It will be undefined when sine theta minus 2 cosine theta is equal to 0. So take this over to the other side and just make it equals. Then you'll get undefined. Right? Undefined or invalid. So sine theta equals 2 cosine theta. We're going to divide both sides by cosine theta and make it tan. Tan theta is equal to 2. Theta will be equal to what? Shift tan 2. 63,43. right? Plus, we're solving for a general solution because we want an answer between minus 180 and 180. So K 180, because tan is positive in the first quadrant only. So there's only one quadrant solution. Now we need to take different values of K and see which ones works. So 63,43 will work because that's between minus 180 and 180. The negative answer will also work by substituting K as -1. -2 will be out of the boundary and 1 will be out of the boundary. So only two answers, one negative, one positive. Let me just put it in order then. 63,43 does work. If I put -1, so 63.43 minus 180. That's -116.57. That's within the boundary. Right, so only those two answers, right? Determine the values of theta for which the identity will be undefined for minus 180 to 180. That makes sense. This was another nice question. General solution of this. Now, determine the general solution of the following equation. Now, what type of equation is this? Now, it's very important that you try to identify and not open up everything. You just see cos, sine. What you need to identify here is these things: sine, cos, cos, sine. So that's, and look at this angle: 2x plus 40, 2x plus 40, x plus 30, x plus 30. Okay. Now, because you have identified the angles like this, now you can say this is the expansion of sine with a minus. So the expansion of sine A minus B. So what's the first angle? 2x plus 40 degrees, subtract x plus 30. Okay, which is equal to cosine 2x minus 20 degrees. Now that was using compounding. Now simplify this. Sine 2x minus x is x, and 40 minus 30 is 10 degrees, which is now equals to cosine 2x minus 20. Now we're going to change the cosine into sine. How? So now we're going to ask ourselves the question, because we got different angles on both sides. So we're going to take the sine and change is, where is sine positive? Sine is positive in the first quadrant and in the second quadrant. So I need to change the cosine into sine. So I need to use co-ratios. So I'm going to use 90 minus and 90 plus. That's it. So I'm going to say sine of x plus 10 is equal to, change the cosine to sine of 90 minus what? The entire angle. Okay, 90 minus the angle. So now you drop the, remember I'm doing quadrant 1 solution. This is, I still got to do 90 plus. So this is x plus 10 degrees is equal to 90 plus 20 is 110 minus 2x. Okay, if you don't want to do that, you just open up the whole thing and then collect all the variables and numbers together. So what we have is 90 minus 2x plus 20 plus k 360. K is an element of integers. Now solve this. We're going to bring the minus 2x over. We will get 3x. 90 plus 20, that is 110 minus 10 is 100 plus k 360. Divide everything by 3. 100 divided by 3 is 33,33 degrees plus k 120. So this is one answer. Or Second answer is changing the sign as 90 plus. So sine of, we're changing the cos to sine of 90 plus 2x minus 20. So we drop the signs on both sides. Remember, we have done something like this before, but I used 270 because I changed the cos. Now you're changing the cos into a sine. Before I change the sine into a cos. Same concept. Just use vertical reduction. Use the vertical line to reduce. So this is 90 minus 20 is 70 degrees plus 2x plus K360. Always add the K360 after you drop and always add it to the right hand side. Now, bring the 2x over, you get negative x. 70 minus 10 is 60 plus K360. X is now equal to negative 60, negative K360. Right, you can leave your answer like this, or you can change this negative into a positive because K is an element of integers. You don't know exactly which integer value it is, right? So I can change the negative into, but it's fine. If you leave it like this, it's good enough. So those are my two answers, right? So I hope you understood that. Nice challenging problem because first you identify that it's a double angle and then you use co-ratio. So yeah, double angle of sine, compound angle of sine. First you identify that it's a compound angle of sine and then you apply co-ratios because you got sine and cos mixture with different angles on both sides. Determine the maximum value. Right. This is more like, when defining the maximum value is more like trig graphs because the value in front of the trig function gives you the minimum or the maximum value. But now remember, this is cosine squared. Because this is cosine squared, we need to change it in terms of some kind of trig function. We need to change it in terms of some other trig function in terms of only sine of the angle or cosine of the angle or tan of the angle. You need to change it in terms of trig function that looks like this. Sine angle, cos angle, or tan angle. All right. Now we got 2 cosine squared minus 1. How are we supposed to change this? 2 cosine squared x minus 1. See this. See what you got here. So we got f of x, which is equals to 2 cosine squared x. See the minus 2. I'm going to break it up in terms of minus 1, minus 1. Why did I do that? Because I can change this into a double angle, not a square. Right, so if this part here can be changed into a double angle, all right? So what's a double angle for this? This is just cos double angle, cos 2x, cos 2x minus 1. Now, if you think about graphs, cos 2x has a maximum value, which is just the number 1 in the front, okay? Has a maximum value of 1, right? And the minimum value is negative 1 of cos 2x, right? So if you want to find the maximum value, remember this is a shifted graph. You moved it 1 unit down. So the max value will be 1. Max value was initially 1, but you're moving it 1 unit down. So minus 1 is going to be 0. And if they ask for minimum value will be minus 1, which is minus 2. Okay. The other minus 1 is for the vertical translation. We moved it 1 unit down. Now, these types of questions are in NBTs. If you are writing early NBT, the earliest one, these are the types of questions that you need to worry about. It's there. All right, let's look at the KZN paper, and then we'll end off after this. I will try to go over it quickly. Right, so we got 1 minus cos 2x over sine 2x is equal to tan x. Okay, because I have all double angles, I got to change it. So I don't have an option with the denominator. I have to change that. So that's 2 sine x cos x. Look at the numerator now. It means that I want to cancel out the 1, right? And then I can expand the cos 2x. So it has to be 1 minus 2 sine squared x. 1 minus 2 sine squared x. The 1 and the 1 cancels out. So you're left with 2 sine squared x over 2 sine x cos x. Now you can clearly see the 2's cancel out. I think we did this problem before, right? The sine x. So now you're left with sine x over cos x, which is just tan x. Okay, which is equals to right hand side. You don't have to write that out. See what they're asking for. Use this identity to find tan of 15 degrees. How? Use this identity here to find tan of 15 degrees. Simple. Look at the identity that you have already. The identity that you have is this. So I want to find tan of 15, right? This implies tan of 15 degrees is equal to 1 minus cos 2 times 15. So cos 30 divided by sine 30. So 1 minus cos of 30 is root 3 over 2. And sine 30 is a half. Okay. So 1 divided by half is 2. So 2 into 1 minus root 3 over 2. I hope you understood how I got a 2 there. Because it's like this is bracketed. So it's 1 divided by half, which is 2. You can put the 2 in the front. Now, 2 minus root 3. That's it. 2 minus root 3. That's my answer. You can type 10, 15 on the calculator and see if you get 2 minus root 3, 10, 15. Yes, I get 2 minus root 3. I hope this is easy because let's see. Simplified to a single trigonometric ratio. How do I simplify this into a single trigonometric ratio? Nothing is difficult here because there's no double angles and stuff. It looks like a normal grade 11 problem, but let's see. Sine 360 plus x, first quadrant is positive, so sine x. Dot cos of 90 plus x, second quadrant, cos is negative. So negative sine x because it changes co-ratio, okay? 90 plus x is in the second quadrant. Because of the 90 is vertical. 90 plus x is vertical reduction, okay? Cos is negative in the second quadrant. That's why. Negative sine x minus sine x remains there. Divided by what's cos of negative x? Fourth quadrant, which is cos x. Okay, you can add 360. Tan of 360 minus x, fourth quadrant, it is negative. Don't write negative tan now. Write negative. Okay, let's write negative tan x here, and then we can change it to sine over cos. Now what we have here? We have negative sine squared x minus sine x over Remember, the negative at the bottom and the negative there can make it positive here. Thus cos x. What is tan sine x over cos x? So see what's happening now. The cos x and the cos x is cancelling out, and then we left with sine. Aha. So the sine and the sine also cancels out. So everything cancels out here. We are left with negative sine squared x plus 1. And then 1 minus sine squared x. And what is 1 minus sine squared? Cos squared x. And that's my answer. So we simplified to a single trigonometric ratio. Last two questions. Determine the general solution of, whoa, what's happening here? General solution of this. How? Okay, this will give us an indication of what to solve, right? How to transform it. Look at this 1/3 sine x. So we got sine x. So change the cos 2x in terms of sine x. So change the cos in terms of sine. So that's 1 minus 2 sine squared x. That's the double angle expansion of cos 2x minus 1/3 is equal to 1/3 sine x. Now I don't want to work with this 1/3, so I'm going to multiply both sides of the equation by 3. So 1/3 times 3 is 1, so that's just sine x. 1/3 times 3, that's negative 1. That's 1 there. No, not 1 there. Be careful. 1 times 3 is 3. Minus 2 times 3 is minus 6 sine squared x, right? Minus 1/3 times 3 is negative 1. 1/3 times sine x is sine x. All right. Now, make a quadratic. So we got minus 6 sine squared x. 3 minus 1 is plus 2 at the end. Take the sine x over, so minus sine x, right? Make a quadratic. Now, rearrange, multiply by negative, so write it in standard form. 6 sine squared x minus sine x, not minus, plus. Minus 2 is equal to 0. Will this work out? 6, 1, and minus 2. Mode 5, 3, 6, 1, and minus 2. It does work out. So it's 2 sine x minus 1. 2 sine x minus 1 and 3 sine x has to be plus 2 now. Let's see. 3 sine x plus 2, yes. So sine x is equal to half, or sine x is equal to negative 2/3. Whoa, you're going to end up with so many general solutions. Okay, over here, the reference angle, we have solved this before, right? Which is at 30 degrees. So first and second quadrant, so 30 plus K360, or x is equal to 150 plus K360. They ask for general solution, yes. Now, where is sine? Don't forget to write K is an element of Z. Let's look at sine negative. Where is sine negative? Is in the third and fourth quadrant. So 180 plus 360 minus. Okay. So reference angle, we will get a reference angle here. Tan inverse negative 2/3. Sine inverse, yes. Sine inverse 2/3. We're getting 41,81. Right. So x is equal to 180 plus 41 plus 0.81. So 221,81 plus K360, or x is equal to 360 minus 41.81. 360 minus answer 318.19 plus K360. So those are your 4 general solution. Okay. So that's how you simplify, double angles and stuff. It already gives you an indication of what to change the double angle into. And these are some of the tricks that you need to pick up as you solve problems. Last one. Uh, for which values of k will this have no solution? When will it have no solution? What are they talking about here? For which values of k will sine 2x plus 30 degrees plus k equals to 3 have no solution? Okay, I think again they're talking about functions here. Sine 2x plus 30 degrees is equal to 3 minus k. Okay, now note 3 minus k, the value of this can be 3 minus k can either be -1, isn't? Or 3 minus k can either be 1. That's a range of sine 2x. So let's solve for this value of k here. It will work if these are the values. What if we shouldn't make it -1? What if we make 3 minus k? If the value of 3 minus k is less than -1, in other words, it goes to like between -1 and 1, it will work. But if it's less than -1 and greater than 1, then this equation cannot be solved. So don't make it into equations. Or 3 minus k can be greater than 1. Okay, we'll have no solution. When will this have no solution? Now we're going to test it out by substituting. So less than -1 or greater than 1, no solution. No solution, no solution. Over here, yes, there is a solution. So negative k is less than -4. K is greater than 4. Dividing both sides by negative, change the inequality. Negative k is greater than 1 minus 3, which is -2, or k is less than 2. So if the value of k is less than 2 or the value of k is greater than 4, then it will have no solution. If the value of k is less than 2, like 1.5, value of k is less than 2 but is greater than 4. Less than 2. Okay, trying to understand this. What we're going to do is we're going to draw a number line and see what they are talking about here. There's 2 here, 2 and 4 there. So if you choose any value which is greater than 4 or any value which is less than 2, values of k. If you choose which is less than 2, maybe if you choose 0, any value, even here, like 1.9, 3 minus 1.9, 3 minus 1.9, you're going to get 1.1. Choose any other value. You're always going to get an answer which is more than 1. It does not work. Choose any value after 4. Maybe choose the closest value near 4. So if you take 3 minus 4.1, yeah, and that will not work. So those are your 2 answers. It's perfect because we have substituted and we double checked. And this brings us to the end of the session. I hope you guys understood everything. Any questions, guys?